Hey guys, happy Thursday. Hope this is going to work a little better than it did this morning. I had a Comcast partial outage in my area, and the upload speed was like 1 megabit or less. So I think this is pretty stable. It's looking a whole lot better than it was before. So hopefully we're in better shape. Hope you guys are doing well. Let me pull up our schedule here, make sure we're all on the same page. All right. We're going to finish out Chapter 2 today, a review of object-oriented programming, and do a little bit more work with inheritance and copying as well, because it'll set us up for the rest of the work we're going to be doing. Yeah, cool. And then we'll have our first lab come Monday, and the labs aren't live stream sessions or anything. The lab traditionally is, here's a lab assignment for you guys to work on based on the stuff we've been talking about the previous week. Again, because we do like Tuesday, Thursday, and then lab, and then Tuesday, Thursday, lab. Our schedule's a little bit off. But the lab will be working on some of these things that we've talked about here in Chapter 2. And I would usually walk around the room and can help you troubleshoot things and figure out whatever else is going on. So there's no content for me to stream, nothing really interesting for me to talk about. It's your time. You don't have to be there during lab time, but I'll be hanging around on Discord, and I can do screen sharing sessions or whatnot. We can fire up Zoom if we need to, and we can go from there to help you guys with troubleshooting. So let me know. But other than that, we'll just keep on moving. Again, we are skipping Chapter 3. Then after today, I'll post the quiz on Chapter 2. You'll have we do next Thursday about 11:59 p.m. or so. So you'll have at least a week to get that one in. And you can open it, you can close it, you can open it, you can close it, you can start it, you can pause it anytime you want during that week. It's not time bound at all. It's open book, open notes, open internet, but it is not open neighbor. Okay? So you're not allowed to work together on it, but you are allowed to use whatever resources you can find online. Most of the questions will be true false. So if you had me last semester, you're familiar with that type, where if the statement is false, you have to correct it and make it true. So it's more like a short answer style kind of question, but some are true and they're just true, and other ones are false and you have to find out why it's false and correct it. Excuse me. And then a couple other short answer style questions. So they shouldn't be too bad. Again, the goal is to make sure you're doing your reading. Anything that's in Chapter 2 is fair game. So things that I say in lecture time and anything from the text is fair game for the quiz. So again, you don't have to read every single word in the book. I get it. That's sometimes it's hard, right? It's dense. There's a lot of material there, and it takes up a lot of time. Ideally, you're doing the reading, but you don't have to go so far as to you've read every word and memorized it. If you know what's in each section, then when you get a question about a particular topic, you can go reference that section. I think is pretty good for what you need on the quiz there. And again, the textbook is your main resource for the course. I'm just giving you the highlights and other examples and things that I think are relevant. Okay, so I think we're good there. We worked a little bit last week with ball and test to write unit tests. We're going to do another class here. So I'm going to create a new Python file. And this one is a boring example, I apologize, but it's really nice for when we're going to talk about inheritance. So we're going to make an item here. So this is a class for item. We're going to define that init method, right? That's our constructor method. And item needs a couple things, right? We need a name, we need a price, and we need a quantity. Right? How many of these things are we buying? Okay, so self name is the name, self.price, and maybe we want to do some sanity checking here. We might want to make sure someone's giving us a valid price here. And we're not doing something wrong like a negative number. So we can do that here in a second. So let's do that. Let's define a set price method, and we could make this public if we want, so that the price can be changed on the item, which probably makes sense because item prices do change. So we'll leave it as public. If we wanted it to be private, we just put that underscore there, right? That's just our convention. So self underscore name, like we'll make that private. So set price given a price. This is where we do our sanity checking. We're going to say if price is less than 0 or less than or equal to 0, or I guess less than 0, we'll just leave it at 0. Maybe 0's still not a great price, but it should be quick enough for us to do some sort of lookup if we're storing this information, like find everything that costs 0, because we know that's something wrong. Otherwise, right, else self.price equals price. That should be self.price. And probably, again, we want to make this a private variable. It's good practice, right? That's the idea of encapsulating all of our details away, making sure they have a public interface to work with. So I don't want you to go change these directly, especially because I'm doing some sanity checking here. If you could go modify price directly, you could go make it negative, and we don't want that, right? So we're going to say, hey, this is a private value, and to do that, let's call self.setPrice given the price here. And we'll probably do the same thing with quantity, self.setQuantity given the quantity. Okay, and a real similar sanity check just to make sure. And in this case, you probably want, like, I'm just doing some copy pasting here. Probably want it to be 1, right? At least 1 for a quantity, but maybe not. I don't know. What do you think? Quantity. So the underscore means it's the convention for being a private value, a value that you shouldn't access externally. And when I go use item other places. So the underscore means, hey, this one is private. Okay. Sorry, my wife just texted me. Oh dear. Yep, so it means it's private. So quantity is the quantity given, as long as if it's, I guess 0 might be okay, sure. We're buying none of this, but that's probably okay. So we can go change the quantity if we want. Sorry, apparently my cat is not doing well. Okay. All right. So we can set quantity, we can set price, and then we want get for all of these, right? If we're saying these are private attributes, then all right, cat's not dead. Yeah, so, well, self is the instance. So item is the class, that's like the blueprint. And self is saying this particular instance of item. Like when we were doing ball, we had a basketball, was these, so anything here, basketball is the self. Baseball was that instance of ball, and it had an attribute baseball, like racquetball, right? So they all get their own, each instance gets its own values, and that instance is the self in any of these methods. So when we called racquetball.toss, the toss method was called, and inside of toss, self was the racquetball instance at that point. So it's just a way of referencing your current instance. So now we're going to need get methods. So we need a way to get name. So we're going to have get name, and this just returns self.name. And we'll have a get price that returns self.price, and a get quantity. Get quantity that returns self.quantity. Okay, so I'm giving you public methods to get this private information. This is a nice convention. If we're not doing any sanity checking around it, it's probably okay to not worry about sets and gets. I'm not going to worry too much about that for right now. That's probably anything more than we need to do for this class. But again, so we said name was private, so we have a name, a get, so they can set it. So if there's no set name, like we have a set price and a set quantity, but we don't have a set name. So name is only set in the constructor here in this init method, which is okay. You're probably not going to change the name of the item, right? If the item name is changing, then we're probably having other stuff happening anyway. And then the last thing we want to do, right? All of this is just boring sets and gets with some sanity checks. The last thing we want to do is have a get total price. Total price. And that's going to return my self.quantity times the self.price. So if you're buying 5 of these things at $1 each, it's $5. Okay? We all right so far? And actually, probably a better way to do this, right? Because we've talked about exceptions. We did that last semester, I forgot. Is to not even just set it to 0. If you give me less than 0, we want to throw an exception. So we're going to raise invalid, or what is it, error? A value error. And we'll say price may not be less than 0. So we're just going to raise an exception. So if you give me a bad value, I'm just going to crash or make you deal with it. So init's not private. The double underscore here is indicating this is a special method. There's a lot of double underscores. like string, or all the operators are all double underscores, get greater than, less than, equal to, absolute value, add. Those are all double underscores. Those are special operators. But it can also mean like extra private, and that part gets awkward, and you can read about that in chapter 2. We're not going to bother with any of that extra private stuff. So init is just, that's the constructor method we want to make an item. So if I say from item import item, well, I guess that's capital I, isn't it? item, yeah, item, there. Import item. Now I can make an item, right? So I can have, nachos equals an item, and then I'm going to call that constructor, and it's going to need the name, the price, and the quantity. Nacho, I want, now it costs what, probably $2.50 for nachos, and I want to eat 3 of them because I love nachos. Right, so that's the init method being called here behind the scenes. We don't actually call init by name. It's just, that's the constructor for it. Okay. So if my price was 0, we're going to raise this value error. I like this. This is better. This is much better. I'm sorry. Should have done that before. Quantity. Now be less than 0. So, and if you raise an error, raise an exception, the code just stops. You don't really need an else block here because it stops running. It will never even get to line 11 if we raise this error. So the else is kind of redundant at that point. Okay. Cool. And it is warning us. It's like, hey, we're setting this outside of init, but we're calling it from init, so we know it's okay. I'm not too concerned. And that way we don't have to do this sanity checking twice, and we can change the price. Okay, so that's our class, right? And then we could write some tests for it. Right, so we're going to say, go to test, and say, I don't have any tests. We want to make some new tests. So we want to test set price, we want to test set quantity. Might as well test get name and get total price. But we're going to do these other gets outside of the testing. Yeah, these are the exceptions here. We're going to go test them. And then we can handle it here in main. So I'm going to test my sets. The get name, there is no set name, so I'm going to test it to make sure that it works when I hand it to the init method, and then the total price. The other gets we don't need to test because we're going to use them in the tests for set. So as we test set, we have to call get to get the value back out. We'll say from item, import item. So for set price, right, we're going to do this arrange, we're going to do an act, and we're going to do an assert. Those got tabbed in funny though. So arrange, the first thing we need is an expected price. Price, right, we said was $2.50 for our nachos. Right, and then we're going to act. Right, so we're going to call nacho equals a new item. Oh, I'm sorry, equals item. And then we'll give it, the name doesn't matter. We can call it nacho if we want. Not a big deal. We give it the name. We give it, why am I forgetting all right? What's in the list? Not helping me. Usually it tells me. The price and then the quantity. Okay, cool. So then the price, and then we have our expected price and a quantity, sure, of 1 is fine. And then we have an actual price, is my nacho.getPrice. So this is why, as we're testing set price, we're calling get right in here, right? So I don't really need to do 2 different tests for them. And then I'll assert self.assert equal. We'll say that my expected price is my actual price. All right, we can run this one. We'll see if that one works. And that one passes. Cool. So we know that was fine. We could also, if we wanted, start off with 0, right, and then call nacho.setPrice and give it the expected price. Either one is okay, because I know the constructor calls it, but this is fine too. I guess we could do that way. We could put that up there and then specifically test the set again here. Let's try that one. No, I've never done gaming, actually. Might be fun, but it's not my area of expertise. Okay, so I moved this up to the arrange because it's not part of the code that we're testing. The stuff you're testing goes in act. That's the code we're testing here. It's probably not too big of a deal if you leave it in act. It's just a convention, so not too big of a deal. All right, we'll do the same thing with quantity. We'll have an expected quantity. And I want to buy 42 nachos, right? Why not? And then we'll call set quantity. Set quantity. And then we'll have an actual quantity. and then we'll call get quantity. And then we'll have the expected quantity and the actual quantity. And we should say these should match, right? So I'll start it off at 0, and then it should become 42 when I set it to 42. Okay, so get name, similar idea here. But now I don't need any of these values, and I don't even need any, I guess we'd have an expected name here. Expected name equals nacho. Nacho. And I could give it the nacho name here in my act. And then an actual name is my nacho.getName. And compared is my actual, or is my expected, match the actual. So again, these other values here, the quantity and price, we don't care about at this point. All we care about is name, because we're doing this at a unit level. We're unit testing individual functions. Make sure individual functions work. Okay, then the last piece here, we don't actually need an expected name here. We have a price is, what do we say, 250, quantity is 42, and then an expected total price or total cost or something is price times quantity. So if I give my new nachos the price and the quantity, I'll have an actual total price, total cost, get total price. Oh, total price. Price. Okay, and an actual total price. So it should be 242 times 2.5. So that's what I'm setting up in my arrange. This is what I expect to get. I make the nacho in act, given the price and the quantity, and then I check it. Does my get the total price? What did I actually calculate in the code? And then I compare the two. Did I actually get that value back? Yeah, that's a lot of money to spend on nachos. I must be really hungry. Okay, so we're testing there. Then the last piece we need to test, because if we look at this here, we're testing this portion and we're testing this portion, but we haven't tested this line. So there's this idea of code coverage, right? How much of the code is actually running when my test is running? And there's tools you can buy. There's probably even some free ones if we look hard enough that'll measure that for you and give you some sort of number like 80% code coverage or 90% code coverage. And ideally we get 100. It's possible to get 100% code coverage. Sometimes that takes a lot of effort and time, and in the real world, people pay for your time. So having 50% code coverage is better than none. Having 75 is better than 50. Yes, but you typically get a diminishing return on that time investment. So 100% code coverage is nice, but it's not always going to happen. So don't be upset if that's not the standard. I just don't want to set you up to be sad about that. But any code that's worth writing is worth testing. Right? And the computer does a better job testing than we do, putting something in main and saying, okay, does it look like it's up, down? Is it for our ball? Was it moving or not moving? That sort of thing. Right? These things get complicated, and making the computer test it is better. So getting some testing is better than no testing. That's the whole spiel here. But we don't have 100% coverage yet. So we want to test, how do we check these raise sections? Oh, okay, I think I'm good still. Still got some bit rate. So we want to now test, this was the working case where we did set it. We want to test to make sure that these value errors happen as well. So we're going to do more tests now with invalid. Oops, undo, shift tab, there we go, set, test set invalid, price. I don't know, like raises error. We'll just say set price raises error, sure, we'll do that. So if we give it a negative value, we're going to crash hard when we do this thing. And I always have to go look this up because I can never remember right now. So Python unit test error. There's a way to say you're expecting an error to happen. And it's a method. There we go. Yeah, assert raises. That's what it is. So we say assert raises a particular exception and the function that we're calling. Huh, that's fun. Okay, yeah, given arguments. Okay. So self assert raises. So we make a nacho, sure, that's all fine. So that all happens here actually in assert. Because it's going to crash, we know it's going to raise an error. We don't actually do anything in act. We do that all in the assert here. So we have, we'll say like an invalid price is -1. So we're going to say self.assert raises, and I should get a value error here. And I get the value error when what? When I call nacho.setPrice. And what do I have to give setPrice? I have to give setPrice my valid price. And this should do it for us. Let's see. It should do it. Yes. So you'll notice there's no parentheses here. I took out the parentheses. Because if you remember way back when we started Python, we said that functions are also objects. So you can pass a function as an object. So we're passing the setPrice function here, not the function call. So if you use the parentheses, you're calling the function, you're invoking it, you're saying, please run. If I don't use the parentheses, it's just saying, oh, here's the definition for setPrice. Okay, and now we get, yes, it raises the exception as expected, which is cool. So if we changed it, right, if we give it a positive number, it should fail because we didn't raise an exception. Right, value error not raised. That's good, right? We want to make sure that it does successfully fail to make sure we did it right. Okay, we're going to do the same thing with quantity. This is set quantity. So this will be an invalid quantity. And we'll give it an invalid quantity on set quantity. Okay, so let's see if that one works. All right, cool. So now we know that this error is happening because we wrote a test for it, and we now have 100% code coverage because I've got inside of this if block. I got inside of this if block. Here, I'm testing all of these. So I can feel confident that I have 100% code coverage, and I'm feeling good. Okay with that? Again, I think this is review from last semester, but if you're just jumping in, this is definitely good stuff here. Excuse me. Okay, the next thing we want to do now we want to take item a step further. We want to do some inheritance. We want to take everything item does, but specialize it, make it a little bit different, because item was such an amazing class. We used it so many places throughout our code that I don't want to change item because we already are using it everywhere. And really, I've got like a special use case for item. I want to do all the things item does, but I want to do them differently. So now I'm going to add a taxable item. Okay, so we're going to say class taxable item. And then in parentheses, we're going to say we want to inherit from item. We are an item. Oh, but it doesn't know what an item is. So we need to say from item, import item. There we go. Now it knows what an item is. So now we are an item. We do all of the things item does. Okay, one of the tricks here, things that usually cause people trouble, is that if your parent class or your base class or your super class, all the same thing, have an init method that takes arguments, you've got to call this. So we probably need these same arguments here. I need all those same things. So I'm going to need a name, price, and a quantity, and then I also want the tax rate or something like that. And what I'm going to do is I want to call my superclass.init, and I want to hand it name, price, and quantity. So super is the keyword to say, hey, the class that you're inheriting from. Is that better? The class that you're inheriting from, call its init method, hand it these things. All that same code will happen. Perfect. Then I can take my tax rate equals the tax rate. And even this, we probably want to be a little bit careful, because sometimes when you say like a rate, people will say 6 for 6% here in Michigan. But other times I might give you 0.06 because that's actually 6%. Right? Or they might say 1.06 because sometimes we just give weird numbers. Who knows what we're going to get? So we might want to do some sanity checking where we check to see, hey, if it's less than 0, great, we like it. If it's more than 1, if it's less than 1, it's probably in a percentage range, right? If it's between 0 and 1, it's good. If it's greater than 1, it's probably as a whole number what they meant as a percentage. So we probably just want to divide it by 100. right, to get that as a percentage value. We could do that. So we could define a set tax rate given a tax rate, and we could say if tax rate, if tax rate is greater than 1, then self-tax rate is equal to the tax rate divided by 100. Else, self-tax rate was probably fine. Tax rate, because so if they give us 6 instead of 0.06 for 6%, we're going to turn it into that. So sure, we could do that. So we'll call self.set tax rate, and that's fine because we could change the tax rate if we ever need to. If we didn't want that to be public, we could just leave it as a helper method too, but that's okay. So we told it it's supposed to inherit from item here in the parentheses. That's how you know where you're inheriting from. So when you define the class, you say, hey, you inherit from item. You are an item. Remember, inheritance is a relationship. So a taxable item is an item. Okay, so we've got tax rate. Then the next thing we want to do is we want to use that tax rate when we are getting total cost or get total price. So we are going to override the behavior here of our parent class item. I don't want items get total price. I want my total price. Look at that. I can even click through. How cool is that? It'll show me, hey, see the base class, super class, see the subclass, see the parent class, see the child class. That's a handy little thing. So what we want to do is I want the superclasses version of get total price times, again, the total price. No, that's wrong. Sorry. Plus. There we go. Times self.tax rate. Self.tax rate. There we go. So previous total price plus total price at tax rate. So at 6% of this will give me the total price, 1.06 now. I guess I could have just added 1 to that. That's probably easier. Plus, let's do times 1 plus self-tax rate and just force the order of operations there. I like that. That's probably better because then you're not having to get the price twice. Right, that makes sense? So when we call get total price on a taxable item, it's going to include the taxes, which is pretty cool. Hey, Professor Peter, thanks for coming on by. If you guys are not up to date on your calculus, you could go check out Prof. Peter's channel. And he even is the coolest math teacher I know because he does some Python programming examples in calculus, which I'm so jealous of that I didn't get a chance to have that when I was learning my calculus. Yeah, we are having fun. So we're doing object-oriented programming. Just still good stuff, but probably not quite as applicable to just straight, here's how you write Python functions. Well, thanks for coming on by, folks. All right, so we have our taxable item. We're inheriting from the item class. So we now have a new function, set tax rate, and then we have an overridden function of get total price. So get total price will do this version, not the item version. But we're still going to use the items version here and then multiply it by the tax rate. Okay, so we could test it. Right, so I'm going to say go to test. Calc, yeah, and coding, it's phenomenal. I'm so jealous. Some little Python coding exercises, and what was the graphing you were doing? It was fantastic. The Riemann sums graphing, I think you were doing. That was so cool. Calculus is awesome, by the way. You say it like it's no big deal, Prof. Peter. You're the only math prof I know that does Python. All right, so we're going to test our setting the tax rate. All right, so we're going to arrange, we're going to act, and we're going to assert. So to set this up, we're going to have an expected tax rate of 0.06. Sure, this is our Michigan sales tax here. Ooh, animated curves. That's really cool. You know, I've actually never done anything animated. I probably should, but we just never get about it. So we need to import. So we'll say from taxable item, import taxable item. I keep hitting some like search option here. I don't know what key I'm hitting, but I'm just typing wrong today. All right, so we're going to create that item. So we're going to make our, what is usually taxable here? I'm trying to remember. Not food, right? They don't tax food, but some prepared foods they tax. Our laws are crazy here. How about a table? Why not? They tax tables, durable goods. Table equals a taxable item. And taxable item needs a name. Sure. So table 1, 1. Oh, maybe we should do like 2 for the price. I don't know. Yeah, they tax alcohol. All right. So let's buy 1 table. And then the tax rate here, let's do 0.06. Or we could even then call set tax rate. Maybe that's even better here. So let's start it off at 0. And then we'll set it to 0.06. And then we're going to have the actual tax rate. Actual tax rate is my table.get tax rate. Oops, I didn't add it. I need to get tax rate. Define get tax rate. Right, we need a public method, way for them to access this value that is a private value. Right, now I can check it. Get tax rate. Okay, and then we'll assert they're equal. Self.assert equal the expected tax rate and the actual tax rate. Let's give that one a shot. Cool, so we're feeling good so far, but we only checked the else here. I want to make sure we're checking the if to get 100% code coverage. As I wrote this code, I want to make sure this code works. So now let's test it again. Tax rate, this is, I don't know what, whole number? So our expected tax rate is still 0.06, but when we give it now, we want to give it 6. Okay, and our code should then turn that into 0.06, because if I'm saying it's 6, as I mean 6%, I really mean 0.06, and we should be mathematically accurate, but that's okay. All right, so let's see if this test runs. Great, so we're getting 0.06 back out, so our code is working as expected. Ooh, I had a math joke. Didn't I have a math joke? Let me see. I had a good one for you guys. I think you guys would all appreciate it. Oh, where is it? Where is it? I've collected so many of them now, it's hard to find. Let's see. The longer it takes me to find this, the less worth it is, but we're committed now. Where is it? I must have lost my math joke. Oh man. I'm upset. All right, I got this one. I don't remember if I told this one or not. It's only math related. I didn't mean to get your hopes up too much, but I don't know. When I was a kid, we always kept the house cold in the winter. Like 68 was as hot as it got, and the thermostat. Yeah, well, so we're testing that if we give it 6 as a whole number, that we're actually converting that whole number into a real percentage, like 0.06. Because we tried it once where we gave it actually 0.06 and it was fine. We want to make sure if we give it like a whole 6, it's getting converted. Anyway, so my house was cold as a kid, and my dad never wanted to turn the heat up, and the thermostat was upstairs, so downstairs was even colder. So I promised myself I would keep the house like at 70 degrees because I wanted to be comfortable. And I'm wearing a t-shirt right now in the middle of winter, and I love it. It's comfortable. Not that hoodies are wrong, so, but I don't know. I just want to be comfortable. So my son was complaining that it's always cold in the house. I was like, no, you don't know how good you have it. We have the house at 70 degrees. Just go put on a jacket if you're cold. And I just sound like my dad, all this stuff. And he keeps complaining that it's cold. And I said, you know what? If you're so cold, go stand in the corner. And he said, well, why should I stand in the corner? There's not a heat vent over there, because they'll stand on top of the heat vents to get the warm air as it blows. And I said, because the corner is 90 degrees. Thought you'd appreciate that one. All right, so we've tested. Life is good. Oh, we didn't test our get total price. Oops. This one's failing, so that's the next one we want to do. So we're going to arrange, we're going to act, and we're going to assert. I guess I could have just copy pasted. Let's do that. So if we make a table and it costs $2 and it's a 6% tax rate, we want to let's buy 2 of them, right? Why not? 2 tables. These are IKEA tables here. Get total price. So my expected total price should be 2 times 2 times 0.06 or 1.06. So 4 times 1.06, and I'm too lazy to figure it out. So I'm just going to ask Python to do it here. So I'll say my expected total price is my actual total price. Because it should get the original total price, which would have been 4, 2 times 2, and multiply by the 6%. How exactly did it test it? So like for tax rate, the expected tax rate, when we called set tax rate, we gave it a 6 whole number, which would be 600%, but we know we don't have 600% tax. So in our code, when set tax rate gets run, we're checking, hey, if you gave me more than 100% tax, you probably meant that as a percentage. Let's just divide by 100. If it wasn't more than 1, you gave me like 0.06, you probably meant it was a 6% tax, because you understand that percentages are decimals. At least, less than 100%. So that's what we're checking. We're checking that when we get the tax rate back out, it's been converted. Yeah, so we're saying this is what it should be, because I know what's supposed to happen in my code. So I know I should be adding a 6% sales tax onto this $4 total cost, because I'm buying 2 of them at $2 each. So we're just making sure it's our sanity check that I know what the code's supposed to do. Let me make sure that it does what I think it's supposed to do. And we're doing it in unit testing, where I can automate this sort of thing and make the computer do it, rather than putting it all in main and saying, okay, let's create an item, let's get the value here, and let's check by hand. Because people are bad at that sort of thing. At least at the unit testing level, we're bad at this. And I run it. Uh-oh. I expected 4.24, and I got none. I got nothing out of get total price. Uh-oh, what did we do wrong? So taxable item, we calculated it, but we didn't return it. Right, so we returned nothing. So we need to make sure we use that return word to give that value back. That was good. That was totally on purpose. Now it works. So if we do the right thing in our code, this is good. We caught a problem with our code because I didn't actually do it. I thought I was doing the right thing. It was calculating it. It wasn't putting it anywhere though. So making sure we returned it was good. That was a good test. You okay so far? Cool. So that's a little bit around inheritance, right? When we inherit, we are that type of item. So if we come back to main here, we just want to take a look at some of these here. So from taxable item, import taxable item. Again, there's no reason to put them in separate files unless you like to. I like to. I like each file to be its own class. It's just my habit. Some people will say that's ugly. Sure, I don't really care. One way or the other. It doesn't matter much. But if I make a taxable item, right, if we were going to buy some beer, and beer is taxable here in Michigan, equals a taxable item, and we'll say this is beer. I want, it probably costs what, it's, was it $10 for a 12-pack or something like that? We're writing our own classes here in Python, and I just want to buy one 12-pack. We'll call that right, 12-pack of generic beer. Probably get that for $10, maybe even less. We're making up the numbers here. But now beer dot, I get all these other methods. And PyCharm is nice and it's telling me, hey, these ones here came from item. These 3 here came from taxable item. So it's showing me, oh, hey, this is an inherited class. Because sometimes you're getting something from item, sometimes you're getting it from taxable item. Which is pretty cool. But because we are an item, inheritance creates that is a relationship, we do all these other things. We can call all of those other methods directly. I can change the price, I can change the quantity, and I can get my additional specialized versions. So inheritance lets us specialize a class. Take the class and do something special with it. And the book is going to do all sorts of inheritance as we get into the data structures portion of the class, because it makes actually a lot of sense, and it saves a lot of time in using the shared components. Some people are shying away from object-oriented programming because we have done a bad job in the industry of abusing inheritance and using it too many places. And sure, that's fair criticism, but it doesn't mean that's a bad thing. I think their reaction to say, oh, we just shouldn't do it anymore is silly. We should just be better about how we do it. So, and, you might hear something like that, but that's okay. And Python is object-oriented, but you don't have to use it object-orientedly. Like, nothing says you have to make classes. All of our previous assignments before we got to classes last semester, we did without classes. We just did it in one big main method here, and we could use functions, sure, and did some stuff, but we never used classes for anything really. But it turns out it's nice for developers. It's nice for people because we think about things in terms of objects and classes, right? A class is just the definition, the blueprint of an object, right? I've got my mug. Mug has a size, mug has a color, right? Those attributes of mug, whether or not it has a handle, whether or not it's a thermal mug, that sort of thing, right? We have all sorts of different types of mugs. So the mug is the blueprint, and then they each have different attributes that make them unique, make them special, and then things that we do with mugs, we interact with them, right? We drink from mugs, and it removes liquid, and when it's out of liquid, it's sad, because then you have no more coffee, right? We could put more liquid in, right? That sort of thing. So the ways that we interact with our nouns, our verbs, are typically those public functions. And its attributes are all these self-instance attributes. All the things that it knows about itself, or maybe item might be better, right? All of its attributes that it knows about itself what makes it unique. All right. Great. You guys with me so far? Cool. I'm going to go make sure I do have a hardcover book somewhere, but I think it's actually at the office, which is, I'm actually not allowed on campus, so I have left it there, but that's okay. So I have a PDF, totally legit PDF that I'm going to take a peek at and just make sure we're covering everything here in chapter 2, because sometimes I miss stuff. Imagine that. Yeah, I'm not scrolling fast enough. I did this badly. I think the super legit PDF doesn't have the jump to sections enabled because it's anyway. Yep. Inheritance. Namespaces is interesting. So when we look at code, you can have variables at different levels or different namespaces. So you can have variables declared inside of functions. So we some temp tax rate equals 1, I don't know, whatever. This is a local variable to this function. Right, so we can define its name here. We can also have class level variables, or these instance variables. We can also have static variables on classes that are defined once and only once, and shared among all the instances of the class. And you can have global variables, and you get all sorts of weird issues if you use the same name. So typically we just don't use the same name, and life is good, because then we don't need to run into it. There's a specific order in which these namespaces are checked. So if we go and try and access a value here, let me find it. This is a big chapter, man. Yeah, don't read every word. Yeah, namespaces, there we go. So it's going to check the instance namespace, and then the class namespace, and then the global namespace, right? Yeah, instance namespace, class namespace. Oh, and then it will check the superclass's namespace, and then that superclass's namespace, and on and up that inheritance chain, specifically for class namespaces, which is cool. All right, and then the other thing we wanted to talk about was copying. So this one here, let's try it. Let's see. That's not. I have some there. Let's do this. Let's make one more class here. A new class, and we'll just call it numbers. So class numbers. Oh, sorry, that's really small. Enhance a little bit here. Numbers has an init method that takes first, second, and third. I don't know why, but that's fine. And we'll have self.numbers, and I'm just going to make this public to make it life easy here. Will be a list given first, second, and third. Okay. We can just make a list. It has first, second, and third. It's nothing super fancy here. I guess I could have just defined it in here, but that's fine. From numbers, import numbers. Okay. And then we'll say first set is numbers given 1, 2, and 3, and then the second set is numbers given 4, 5, and 6, and a third set is equal to the first set. And then let's print first set dot numbers, and we'll print second set dot numbers, and then we'll print third set dot numbers. So we should get 1, 2, 3, 4, 5, 6, 1, 2, 3, because we said third is equal to the first. Oops. Tax rate. Oh, I forgot the tax rate. 0.06. That's why I didn't like it. Right? So 1, 2, 3, 4, 5, 6, 1, 2, 3 again. So if we wanted to go and change one of these, we could say first set dot numbers at index of 0. Let's change this 1 here, right? Let's assign that the value of, say, 20, just for fun. And we're going to print them out again. We get 1, 2, 3, 4, 5, 6, 1, 2, 3. And then we get 20, 2, 3, 4, 5, 6, 20, 2, 3 again. Well, what happened here is third set is the same variable as first set. We said, hey, you are this one. So what we get here in memory, we can take a peek when we debug this here, is they're the same object. Oops. You were wrong, debug. Whoa. Oh, probably shouldn't call that numbers. Okay, let me just, it was upsetting it here. I'm just gonna pull that out. Put this over here. I'm cheating here because you got upset with me. If you name something that's a Python reserved word, like numbers apparently was reserved in Python and already used, you got upset with me. Okay, so here we go. So now we can debug. Oops, we don't need that one. So let's keep going. Oh, I didn't want to rerun. That's fine. Okay, so we're at third set is the first set. So we have first set is some location in memory here, right? This ugly looking spit out printout here. And then we'll get our third set is that same location in memory, B710, B710. So I didn't make a copy of it. I just said I now have two values with the exact same address. So it's two variables pointed at the same location. That's not cool, right? That's going to cause all sorts of trouble. So what we can do is instead we can ask Python to make a copy of it. To do that, it's called copy.deepcopy. And copy is awesome. I think we have to import it. No, I have to import it. Import. Import copy. There we go. Let's give this a shot. Now when we run it, Python automatically for us behind the scenes will make a new version of this object. Copy it. So now third set does not point to the same location as first set. It is a copy of the first set. This is amazing and fantastic. Does that make sense? What this idea of a deep copy? It's not two variables pointed at the same location. It makes a whole nother instance, plops it down in memory somewhere else for us. And this is just built into Python, which is so cool. So we can just use this when we want deep copies. Other languages, doing this in C++ is the biggest pain in the butt, because you have to define how a deep copy works when you do these things. It's no fun, and it takes up a lot of time in your second semester of C++ figuring that out. So another great term, what we did originally here, like third set equals first set. This is not making a copy, but a good technical term, I like how the book does this, it's an alias. He said, hey, another name for first set is third set now, because we now have two variables pointed to the same thing. So it's really just an alias. It's two names for the same thing. Right, so this is an alias. It's two variables pointed to the same object. This is an actual copy. Does that make sense? Cool. Okay, so I think we're good here for chapter 2. Talked about inheritance a little bit. Talked about deep copies. So this it is important if we're trying to make copies of things. And we don't always need copies, so it doesn't always come up. But it's just something to keep in your back pocket. If you're trying to make one thing be a copy of another or equal another thing, like when we did, like number equals 10, and we had another number equals number. Right, we did stuff like this, and then I would say another number equals 20. You guys remember what happened? You got number and another number, and I step. Now I have number is still 10, but another number is 20. Because when we're dealing with things, it's not really an object at this point. This is just the primitive value 10. This is taking the value of it, not you point to this object in memory. So when we're dealing with objects and we start talking about object-oriented programming, it becomes much more important. So previously when we had strings and we had integers and floats and doubles and whatever, our numbers, that didn't matter as much because it would assign it by copy here. Okay? That idea when we're doing functions, we would pass things by copy or pass by value or pass by reference. So just need to be careful. Like when we pass a list to something, we were passing the reference to the list because it was a list object, and we could modify the original list. So if we wanted to pass a copy of a list, we would pass a list slice, and we would just slice the list with that colon notation and say, hey, here's a copy of the list, so you don't change the original. So just something to be aware of and be careful. I'll back that back out because it's not all that important here. So it's all about objects. So if we have an object we're dealing with, we're going to run into trouble with copies. Okay? So I'll post a quiz for chapter 2 a little bit later for you guys. And then we'll have lab on Monday. We're going to practice a couple of these things. We're going to use some of what's in the textbook. And then we're going to look at, I think all you guys are in at least Calc 2 now, right? Is that correct? We're doing Calc 1 while you took 1501, I think. Does that ring a bell? I think that's what it is. So there's this really cool sum of a series in math where you have this R value, and it's really cool. So we're going to do, this one here, a geometric series. Awesome, thanks, Lee. Whoa, that was crazy. So you might not have gotten to this yet in your calculus class. So that's okay. Sequences and series, because we get to that in Calc 2 a little bit later usually. But it's this really cool thing. If you have some sort of series, it's a geometric progression. And the book actually does this in chapter 2, which is fun, where we're getting smaller. Like half, and then 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 half, and half, and half again. As long as we're getting smaller, we can find the sum of that series. If we're getting larger, obviously it's going to go to infinity. Like when you talk about limits and things, like you did back in Calc 1. But the sum, as long as our R is less than 1, we're going to be able to find a sum. It's infinite. Oh, sorry, the absolute value is less than 1. It's been a little while since I did calculus, but we'll prove this with a little function here, which is fun. So hopefully you'll have fun with that in lab. All right, so we'll do that on Monday. We'll have a lot of fun. I'm still trying to figure out if we can do the Unix lab or not. I have to spend a little bit of time working on that, but it's a fun little exercise to run Python in Unix. But I got to make sure we have all the right tools for it. I'll take a look at that later. So we'll do this lab, the series lab on Monday. All right. Again, you don't have to show up in person. I mean, we're not showing up in person at all, but you don't even have to be there at that time if you don't want to. But I've got that time set aside Mondays 2 to 3:45 to answer questions and help you guys walk through it if you need it. Okay? So I'll work on posting that quiz for you in just a little bit, and then we'll be good to go till Monday, and then we'll be back on Tuesday to talk about recursion. This is one of my favorite topics. So we'll have a lot of fun with recursion and solve mazes and Sudoku and that stuff. Okay? All right, it's been fun. Should we see if anyone else is around on Twitch who might want some visitors? Let's see. And if they're if it's turned on. Let's see. Who is around? Oh, my list just changed. Not prof. It looks like he's in math lecture right now. I don't know if we can join there for more math. No, I don't have anyone else at the moment. Is anyone else in Discord around? Oh, come on. That's the wrong one. Let's find the Knowledge Fellowship. Oh, Fusion? Guitar tunes. Huh. Now let's try one of these for fun. Oh, where'd it go? I don't know how to use my computer. Fusion 360. Oh, bother. Try that. Oh_bother. I've never checked out that channel before. This should be fun. All right, raid's totally optional. Let's see if we can have some fun here. Oh, bother. He's on the list. He must be official. All right, guys. I'll see you over there in just a little bit. And if not, I'll talk to you guys on Monday. And I'll hang out for office hours after as well. You guys take care.
Which I guess we can show off.